Hello and welcome back once again to another one of these videos. If by any chance you have not seen this in class, well, I recommend you guys be in class because those conversations wind up being 30 minutes instead of 15 minutes, where people get to answer questions back and forth, and I can't do that in videos. So I highly recommend that you do pay attention in class, because I imagine looking at these white screens for these videos is probably not the most thrilling and enthralling lecture you've ever had from your school teacher. So, last time we talked about how we speak to computers. Now how about we speak how computers talk to each other? So I want you to imagine, here, let me just say over here, this is us. And I'm just going to say, where's Google located? California? I want to say it's California. So we're just going to say this is Google over here. Those of you going with a map are going, hey, wait a minute, you're on the East Coast, Google's on the West Coast, why'd you flip it? Because I read left to right, and that was just the first thing I put up. So, oops, I'm going to have to get rid of that ability to scroll left and right for my next video. And basically, we have a computer here and a computer here. And how does this computer talk from this over here to over here? Now, in the perfect world, it would literally be a straight line from us to them. Here would be the problem. That's not how the world works. So, it's not like that. Instead, our computer will have to go through different things. So let's just say, here's us right here, here's Google right there, and let's just say we're here in the East Coast and we have to go to a server in New York. And then we have to wind up going from New York to, I don't know, Vancouver. And then from Vancouver to, I don't know, we'll just say Chicago. And then Chicago to, I don't know, Nevada. We'll say Vegas. There we go, Vegas. And then we'll just go and say, then we have to hit Seattle, and then we're in California. So we have to make this big, giant, wonky step where it goes boop, 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 boop. And then that's how it gets there. And we're essentially saying, hey, we want our information. Okay? Hey, people over here want information. Oh, they want information. They want information. Send it along. We want information. We want information. We want information. And then Google gets the request and says, hey, we want information. Oh, let's take a little look. Any viruses? Anything negative that we see? Nope, we're good. Let's go back. Give them access. Hey, they get 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 access. And it goes all the way across the country, and then it goes all the way back. Once again, pretty much instantaneously. You know, maybe there's a couple seconds delay here and there, but, you know, you're traveling across an entire country. What can you do? And that's the big, easy point of it. But there might be a situation where, say, I don't know, what do we say, this, Nevada? Okay, so we're just saying this one, there's something really screwy happened here. There was like a giant fire or something at a mainframe, so it's just all screwed up. So we can't go that way anymore. So what does our computer have to do? Oh, well, you see, thankfully, the web is not one big giant thing. There's, you know, all these other lines of progress that we can go around and perhaps, you know, go wherever which way we want. So maybe this path also goes here and goes here and goes here and goes here, goes here, goes here. Maybe also this path goes from here to here to here, 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 here. Maybe our path goes from here, 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 here. Maybe we also have a path that goes boop, 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 boop. Maybe we also have a path that goes boom, boom, boom. And have one goes up there, and it goes that way. So it doesn't matter if this path right here, you know, and I'll just delete that and I'll just make this one red just so we can clearly see that it is the problem area. It doesn't matter that that red one is broken. We can just take a different path. Now, those paths might not have the same sort of traffic ability, like this one right here can serve so much more traffic as opposed to this tiny little one right here. So, if we somehow wind up on this path, we're going to be bottlenecked right here because that one's really tiny and is not used to holding so much data. So it might be very slow. You ever wonder why some days it seems like your internet is just really, really slow for no apparent reason? Well, probably a server's down and it had to take a different path. But because it had to take a different path, it's actually, you're taking a path that now has not only its usual amount of traffic, but everyone else that's trying to go and circumvent around this. You ever drive on a highway where, oh hey, there's a traffic accident up ahead. What happens? Traffic goes to a crawl on this lane, but then there's also that path where everyone goes, wait a minute, there's traffic this way, I'm going to take the turn right here. And then when they take that turn, oh, everyone else took the exact same turn. So now this way is also a little bit slower than what it normally would be. Okay, I mean, you'll still eventually get to where you want to go, perfectly fine. You will eventually get there. But then you're probably asking yourself, wait a minute, wait. But what about if Google itself is down? What if Google is the thing that is all red and, has a big giant error? Well, then it doesn't matter which path you take, you're not getting to Google, because Google itself is down. Any of these dots along the way can be broken, and eventually we will find what it is we're looking for. The only ones that cannot go down, when I click the correct item, are these two blue ones. If your computer goes down, or their computer goes down, you can't get the information across from either end. Any of these white ones can go down, and eventually you'll find a way around it. But these two endpoints cannot be taken down. If they get taken down, that's the end of the transaction. Nothing you can do will help. You're just going to get a 404 error, page not found. You're not going to get there. So, that's how your computers talk to each other. And that's also the same way your phone works. You have your satellite, you have your signal, goes up, bounces off a radio tower goes to a satellite, radio tower, boom, to, the nearest, cell phone or whatever. Same thing with pretty much any sort of piece of technology. It's just a giant bunch of relays in a relay race. As long as the two endpoints are working, eventually you will get there. So, that concludes this lecture, and I will see you in class, hopefully.